All right, guys, well, let's go ahead and get started with our Algebra 2 final review. This is going to be on Category 2, describing and graphing functions and their inverses. So we're going to be discussing, again, graphing functions and some inverses here. So let's go ahead and get started. For Category 2, so we'll be going a lot over the graphing, describing and analyzing, making predictions. We'll have to graph inverses. We'll have to graph the functions themselves. We'll have to check to see if two functions are inverses of each other using composition, and even some regression. For this class, we'll be doing a little bit of linear, quadratic, and exponential function regression. For this review, we're going to be focusing directly on quadratic, but I will mention the other regression formulas as well. So let's go ahead and get started. So for this one here, it says if f of x equals the absolute value of x minus 2 for x is greater than 2, then which of the following represents f inverse of x? So inverses of absolutes is very interesting. What we actually need to do is we need to solve for both cases. What I mean by that is technically what we have here is we have f of x equals x minus 2 is one case, all right? And then we know that we can essentially switch the equation to where we have f of x equals negative x minus 2, and this would be the other case. So we want to solve for the inverses of these two. So what we'd end up getting is y equals x minus 2. We want to switch our x and y because we are solving for inverses. So x equals y minus 2. And then we want to isolate y, so we'd add 2 to both sides. And we get here that x plus 2 equals y. So f inverse of x equals x plus 2. So this is one inverse. And then we'll talk about the domain in just a bit. For the other situation, we have y equals, and we're going to distribute this negative to both values here. So we'd have negative x plus 2. So when we switch our x and our y, we would get x equals negative y plus 2. So then when we subtract 2 from both sides, we get x equals, oops, no, not x equals. We get x minus 2 equals negative y. And so this just ends up being negative y equals x minus 2. We want to get rid of that negative, so we get y equals negative x minus 2. So these are our two, and actually this should be, and we're going to represent this correctly, our other inverse, f inverse of 1. So we have x plus 2 and x minus 2. Well, we have negative x minus 2, right? So we have x plus 2. This first one we can already cross out because we don't have an x minus 2. We have an x plus 2. X plus 2, and then this 2 minus x, okay? Even if we were to switch these values of negative x and negative 2, that still wouldn't work out. And f inverse of x does not exist. F of x is not 1-to-1. That's not true, so we can cross that out as well. Now I do want to make sure that we understand how do we get this as our domain. X is greater than or equal to 0. So in this case, we have this 2 value here, right? To solve for our switching of x and y, what we need to get is we need to get what is y when this is true. Well, when I plug in 2 in here, we'd get 0. So that means that y equals 0, right? And when we switch our x and our y, well, now x becomes 0 for our inverse value. When we switch, remember those numerical values switch as well. So this needs to be true, that x is greater than or equal to 0. X is greater than or equal to 0. So this statement ends up being B. Okay. If at any point you need to rewind this, go over this again, by all means. If you still have any questions, please send me a message on Teams. This is your question. I want you to do the exact same steps that I did here. I want you to solve for the inverse. So you're going to get two inverses, okay? And you also, I want you to solve for your domain value as well, just like I did here. Hint, hint for that domain, you're just going to plug in here, and whatever you get is going to be your domain for your inverses. Let's go ahead and move on. Okay, so if f of x equals x cubed plus 2 and f g of x equals g f of x equals x, what is g of x? So this is a definition here, and all this means is inverse. As soon as you see one function composed into the other and it equals the opposite composition and they both equal x, well then those two functions are inverses of each other. So they're giving us f of x, they want us to solve for g of x, so I'm solving for the inverse. So if I have f of x equals x cubed plus 2, and I'm solving for the inverse, well I'm going to set this equal to y equals x cubed plus 2. I am then going to switch my x and my y. So I get x equals y cubed plus 2. And now I want to isolate y. So I'm going to subtract 2 from both sides. And I'm going to get x minus 2 equals y cubed. And lastly, if I want to get rid of that cubed, I need to take the cube root of both. And so I get y equals the cube root of x minus 2. And that cube root is all the values, so it's got to be letter C. Okay. If you see here, A only has a cube root of x, and it's a plus 2. We should have a minus 2. B doesn't include the negative 2 within the radical. C, we already said was good. And then D has a plus instead of a minus. So again, you just need to understand the definition of an inverse, ask and understand what that question is asking us to do, and then solve for the inverse of that function. Okay. So for this one here, I'm stating the same thing. You're being asked to solve for the inverse, so you're solving for the inverse of f of x equals x cubed minus 5. Okay. Let's go ahead and move on. So here it says, which of the following is a graph of y equals 2 log base 2 of x plus 4 minus 2. Now, you can do this by hand, or you can use Desmos. And just for accuracy's sake, and I want to make sure that you guys get good practice with Desmos too, put it into Desmos. That's what I've done here. And so right away, for speed purposes, I can see that my graph is going from left to right, is going up. So I can immediately cross out A and C. Now B and D look very similar, and a lot of students are going to be real prone to just select B because it's the first one they see. What we want to do is when we want to look at certain characteristics here, I see that we have a vertical asymptote at x equals negative 4. Well, both of these have that. That doesn't help. I see here that the graph crosses the x-axis at negative 2, 0. Well, both graphs do that. So that didn't help either. The next thing that I want to look at is that y-intercept. My y-intercept is up here at 2, 0. I'm sorry, not 2, 0. It would be 0, 2. At 0, 2. And this is at 0, 1. And up here is at 0, 2. So this has to be our answer. Use Desmos, but be very careful. The graphs do need to match exactly. B is really close, but it is not the graph. Okay, let's go ahead and move on. For your question here, I just want you to graph this logarithmic function here, be detailed with your vertical asymptote. Okay, be detailed with your x-intercept, and be detailed with your y-intercept. Okay, that's what's going to make your graph stand out. Let's go ahead and move on. This one here says, what is the smaller of the two solutions to the equation given below? So for this one here, what you could do is you could graph this in Desmos and kind of see where those x-intercepts are. If it's decimal answers, which we see here, it's going to be a little tricky. So what we actually want to do is we want to solve this by hand. And like I said, you could use Desmos to check your work. We have 2 absolute value of 4x minus 5 minus 2 equals negative 4. And so we kind of want to use the KISS method here, which was the keep it, switch, switch. That's typically used for inequalities. But it works here as well. That's, again, KISS is keep it, switch, switch. But I can't do this until I isolate my absolute value. So what I'm going to do first is I'm going to add 2 to both sides. This simplifies out. I get negative 2 absolute value of 4x minus 5 equals negative 4 plus 2 is negative 2. I then want to divide both sides by negative 2. And so I get the absolute value of 4x minus 5 equals negative 2 over negative 2 is 1. So here what I'm able to do on this first set, okay, this is now what I can use my KISS method for. The first one I'm just going to solve as is. So I'm going to say 4x minus 5 equals 1. I'm going to add 5 to both sides. So I get 4x equals 1 plus 5 is 6. Divide both sides by 4. And I get x equals 3 over 2. So this is a possible answer. Okay, I see 3 over 2 here. Now, we do know that we're going to get another answer when we do the KISS method, which we keep this first part. We're just going to say 4x minus 5. To switch an equal sign means just keep the equal sign as is, and to switch that 1 would now become a negative 1. And now we solve this scenario. So we're going to add 5 to both sides. Simplifies out. Okay, so we're going to have 4x equals negative 1 plus 5 is a positive 4. We divide both sides by 4. And we get x equals 1. So this is also an answer. Now, it's asking for which is the smaller of the two. Well, 3 over 2 is the same thing as 1/2. And 1 is 1. So this guy is the smaller one. So we got this here. So you need to be able to get both. That's a skill here. And then you also need to be able to understand what is the question asking us to do. Okay. Let's go ahead and move on. Okay, so this is your question. I want you to just solve for the 2 solutions. You don't need to tell me which one is bigger or smaller. I just want you guys to solve for the 2 solutions. Okay, so you will need to use that KISS method used in the previous problem. Go ahead and go back to that problem if need be. All right. Or just send me a message and ask me questions on Teams. I'm more than happy to help. So for this one here, it says 4 functions f, g, h, and j are defined in the table of values below. Which of the functions are not one-to-one? So for one-to-one functions, okay, one-to-one means, let's do this, 1-to-1 means x's don't repeat for the function. Repeat for the function. I can't spell today. And x's don't repeat for the inverse. Okay, so the x's can't repeat for the inverse either. So what's happening here is like these values of x, so the 1, 2, 3, 4, 5, 6, these are the x values, right? And these are essentially our y values here. So our x's for everyone, f, g, h, and j, those x's are 1, 2, 3, 4, 5, and 6. So they never repeat. So now if we were to switch these, and f of x now became our x values, well, they can't repeat. I have 3, 7, 1, 6, 2, 4. Okay, so I don't see any repeating values here for f. For g, okay, if I check g, 8, 3, 7, 1, 6, and 9. Nothing seems to be repeating there as well. Okay, so that is also 1 to 1. H here, so I'm going to put a little check mark, not repeating, not repeating. H says 2, 6, 8, 5, 3, 1. Nothing was repeating there, so that is 1 to 1. And then for J here, 2, 8, 4, 2, 1, 7. These two values repeated in this row. This J function is not 1 to 1, so that is our answer here. Okay. So for this one here, I want you to tell me, is the relationship 1 to 1? Why or why not? You want to check in one order. So if the function is, you check your x, your y, x, y, x, y, x, and y. You want to see, are any of those x values repeating? If not, then go on to the inverses where we'd have y, x, y, x, y, x, y, x. And then tell me if any of those x values are repeating. If neither one of those x values is repeating, then it's 1 to 1. If something is off, then it is not 1 to 1. Evaluate this and give me your answer. Let's move on. So this one here says the table below gives the number of millions of short tons of newsprint Y produced in the year 1990 through 1993 in the United States. So we have these values. It says if T represents the time in years since 1990, which of the quadratic, and this is super important, quadratic models is the best fit. So this is a regression question. This has to, I repeat, has to be done in Desmos. So quadratic regression, I'm going to put quad regression. For quadratic regression, you need to use the equation y1, and this little tilde, a1 squared, there we go. It would be a x1 squared plus bx1 plus c. And we put in these tables. And the table matches exactly, this is my x and this is my y. Now what's important when we have years is you never ever want to use the years. You always start with the first value as 0, 1, 2, 3. Again, never use the years, that's a trap. If you use the years, you're going to get incorrect values. Okay, so when we're putting this in here, our x values would be 0, 1, 2, 3. Our y values would be 6.6, 6.8, 7.1, and 7.1. We put these into the data table, and we see here it graphs it, and it gives us our parameters here. So we get that a is negative 0.05, so we can immediately cross out here and here. Our b value is 0.33, so we know that this guy here is wrong. So this is wrong, this is wrong, this is wrong. And then just to make sure that C is correct, we have 6.58. Perfect. This is our answer. Our A's, B's, and C's all match up. Had this been a linear question, and this is just extra information, that's good to know. Linear regression, okay, would be y1 tilde, okay, a x1 plus b. And this could also be a scenario, but it just depends if the question is asking us for linear or quadratic. Okay, this one does take some skills. We've done regression almost every unit. We did linear regression, we did quadratic, we did exponential regression, power regression. So depending on the equation is the way you're going to want to be setting these up in Desmos. It has to be done in Desmos. Don't guess, and don't try doing anything by hand on these. Okay. So now here on your question, we have these data table. Okay, and I'm going to tell you right now. Okay, this is going to be quadratic, And so we have years. What did I say about years? Go back to the last question. If you don't remember how to set up those years, and I want you to give me the equation, and then I want you to tell me, is this a strong line of best fit, and how do you know? For those that don't remember, this is going to be our r squared. I'm not going to remind you what that needs to be or what it should be close to, but I want you to answer that to the best of your ability. Once you have that set, I will give you feedback in class. Okay, I want to probe your minds a little bit. Okay, let's go ahead and move on. It says here, if the graph of a parabola has a directrix of y equals 1 and a focus at 0, -1, which of these equations represents the parabola? So they're giving us some information, directrix and focus. And so we need to figure out, are they giving us information for horizontal or vertical? Well, right away, I'm looking at these focus values, all right, P0 or 0P. So focus, I have 0, -1. Okay, so already this means that this is no good, so I'm not doing horizontal. Okay, I do want to make sure that I get the proper equation. So I don't need to know what y is, I don't need to know what x is, but I gotta know what p is. Well, p is given to us. P is whatever that y value of the focus is. So P equals -1. So when I use this in my equation, I'm going to have y equals 1/4 times -1, all of that times x squared. So what that -1 does is it makes this whole fraction negative. It'd be -1/4 times x squared. Okay. We don't have a 0 here. They didn't give us any type of 0, again, because x is 0. So we do have a +0 here. The equation itself is in y-intercept form. And if you look at all of our answers are in standard form. So none of these match yet. So we want to have all of our values, our x's and our y's here on the left side, and our constants on the right. So to do that, I want to add 1/4 x squared to both sides, plus 1/4 x squared. So these would simplify out, and what we'd end up getting is 1/4 x squared plus y equals 0. So I'll look here. Well, a is no good because it has that negative. B is no good because it has that negative and this -1. Okay, C, there we go. There's our answer. And then D was no good because it has this -1 here. And we are all done. Okay. Let's go ahead and move on. So for your problem here, same information is given. Pay very close attention to how you get your p value. If you're not sure, this question is exactly like the one before. So make sure that you guys get your p value. Okay, and then from there you'll use your equation, and you want to then get your equation in y-intercept form and then rewrite it in standard form. All right, so let's go ahead and get moving. Okay. This problem says here, the coordinate plane has been used to draw a flag design as shown in the figure below. And then it says, which set of absolute value equations represents the flag design? So this is a really neat question here. What's important to see is that we have two, and I'll draw one here. This is one absolute value, and then here in red is another. So let's look at the one just in purple, and I think that one's kind of neat. We can already find that vertex. This vertex, if we're starting here at 0, I have to go 1, 2, 3, 4 units to the right. So that means I have an absolute value of x. If I'm going 4 units to the right, it'd be x minus 4. and I'm having to go 1, 2 units up, so that's a plus 2. So I already know that my equation needs to look something like this, x minus 4 plus 2. And so knowing that, I can already see that here, that A is a possible scenario, right? X minus 4 plus 2, I have that there. B has x minus 4 plus 4. That's too big. That's going to move us all the way up here, and that's no good. So this is no good. C also has that plus 4, so that's no good. So we are left with A and D. So what we could have done too is we could have just started putting these answer choices in Desmos and see which ones match. That's an idea, but I want to make sure that we don't waste time. And just knowing these transformations, we're able to save a lot of time there. So then what's the difference? We have times 1/2, right? We have these times 1/2 and negative 1/2, and times 2 and a negative 2. So then how do we do this? Well, we see here that if these had just been basic absolute values, we would have had a 1-to-1, right? Where we go up 1 over 1, up 1 over 1, up 1 over 1. Now we see here that we have a vertical compression. So vertical compression. And so when I'm looking at this point here, this main point, and if I'm looking at my slope, to get this I have to go up 1. Remember, this is rise over run. So I'm going to rise 1 and then go over 2. 1, 2. And so this is how I get my 1/2 slope. That means that A has to be my answer choice here. Okay, if you want to use Desmos to check, you can definitely use Desmos to check these out. Okay. All right, so let's go ahead and move on to yours. What I want you guys to do here is I want you to identify the transformations for this vertical function. Are there any reflections? Is there a vertical stretch or compression? If so, what is it? What are the horizontal shifts and what are the vertical shifts? So just give me the properties and transformations of this absolute value function. So that concludes our Algebra 2 review, Category 2, which dealt with a lot of inverses and transformations and graphs. If at any point you have any questions, let me know, speak out in class, or send me a message on Teams. I'll be more than happy to help you. Be sure to get this done, as the following day you will be getting Category 3. All right, bye guys.